Dear student, in the lecture 2 of our chapter alcohols, phenols and ethers, now we are going to discuss the preparation of alcohols and phenols. First of all, we will take the preparation of alcohols. Preparation of alcohols. In the preparation of alcohol, first of all, we take it from alkenes. We know that alkenes are unsaturated hydrocarbons which have double bond in it. The preparation of alcohols from alkenes is in acid catalyzed hydration. It is in acid catalyzed hydration. It means that acid catalyzed hydration means the water molecule is added to an alkene and this reaction is catalyzed by an acid. In this reaction, we know that if this alkene is unsymmetrical, if this alkene is an unsymmetrical alkene, then this reaction will proceed by the according to Markovnikov rule. Here we will take that if we will add water in an alkene, the alkene will break its double bond and water molecule will attach to it. It is a addition reaction. It is an addition reaction in which one part, that is negative part, will attach at one carbon and the other part, that is H positive ion, will attach on the other end. Here we will take the case of an unsymmetrical alkene. This is an unsymmetrical alkene. This is propene. When we add water with it and in the presence of an dilute acid, the product will be this compound. Here we can see that the negative part, that is OH, will attach to the carbon which has less number of hydrogen atoms, that is which is more substituted, and the hydrogen part, that is the hydrogen part or H positive ion, that is attached to the carbon which is less substituted, that is more number of hydrogen atoms. This is the product which is according to Markovnikov's rule. This is according to Markovnikov's rule. We can name this compound. This is propane 2-ol. Now we will look the mechanism of this reaction, because mechanism of this reaction is given in your NCERT book. So the mechanism of this reaction, here we can see that this reaction is a three-step reaction. This is a three-step reaction. In the step 1, the protonation of alkene, here we can see that this is a water molecule and when it attach with the hydrogen ion, B will get hydronium ion. This is hydronium ion, and this will behave like a electrophile. Although this hydronium ion don't have vacant d orbitals, but further it will behave like a electrophile. Now in the hydronium, here in the hydronium ion, we can see that there are three hydrogens attached to this oxygen, and therefore this oxygen has a positive charge. When this hydronium ion reacts with an alkene, this hydrogen will polarize its electrons towards oxygen, and therefore this hydronium ion behave like an electrophile and pull these electrons of the double bond of these carbons towards itself, and the reaction will proceed like this. This is a carbocation, and the formation of this carbocation is due to the cleavage of this double bond. Here the double bond is cleaved between these two carbons, this double bond cleaved, and hence these electrons will go to make a bond with this hydrogen. Here this is the bond which is made with hydrogen, and therefore this carbon will lose its tetravalency and it will get a positive charge, and therefore there is the formation of a carbocation. We can see thus that this carbocation is a tertiary carbocation. Tertiary carbocation because there are here we can see that this carbocation can be tertiary or primary or secondary. It may be any of these. If only this carbon is attached to only one carbon, it will be primary, and if there will be other carbons, two carbons, it will be tertiary, or one carbon, then it will be secondary. The order of the stability will be tertiary, after that secondary, and after that primary, due to the plus I effects of these carbons. Now we will see that with this the water molecule will also be there. This is the first step of the mechanism, which is the protonation of alkene. This is the protonation of alkene to form a carbocation by the electrophilic attack of this hydronium ion. Now we will see the second part of this mechanism, which is step 2, that is the nucleophilic attack of the butter on this carbocation. Now we can see this carbocation, and this is a butter molecule. Butter molecule will have the lone pair of electrons, and with these lone pair of electrons, butter molecule will attack on this carbon, and it will form a intermediate like this. Here butter will attach with the carbon through the oxygen atom, and because this oxygen will join the carbon, therefore it will get a positive charge. This is the second step, in which there is the nucleophilic attack of the water on the carbocation. We can write it as the second step as a nucleophilic attack of water on carbocation. After that, we will see the step 3. Step 3. We can see in the step 2 that this compound is not a stable compound. It is a charged compound. Here oxygen have a positive charge and the compound is not a stable compound. Therefore, in the step 3 there will be rearrangement of this compound and there will be deprotonation, that is the loss of H positive ion. Deprotonation to form the alcohol. To form an alcohol. In this case, our this intermediate, in which the oxygen atom has a positive charge, when it reacts with this water molecule, the H positive ion, this lone pair of electron will get this hydrogen from here, and as a result, by the cleavage of this hydrogen, this bond will cleaved and the pair of electron will go towards the oxygen, and hence our product will look like this. OH. And with that there is the hydronium ion. This step can be named as the deprotonation. Here hydrogen, that is proton, is cleaved from this compound and go towards the water molecule, and rest of the compound is an alcohol. This is the mechanism of the formation of or preparation of alcohols from the